friends, in the previous video we have completed up to the question number 7. Now we'll start the question number 8. Find the approximate value of the function f of x is equals to in root of x square plus 3x at x is equals to 1.02. X is equals to 1.02. Yeah. A is equals to 1 and h is equals to 0.02. F of a plus h is approximately equal to f of a plus h into f dash of a. Therefore, we will calculate the value of f of 1 and the f of 1 f of 1 dash, that is f dash of 1, that is these are the value. Now here f of a, that is f of 1 is equals to in root of, here x is replaced by 1, that is in root of 1 square plus 3 into 1, that is 1 plus 3 and that is a root of 4 and which is equals to 2. Therefore f of a is equals to 2. Now our next value is, that is a f dash of a. For that, what function we have, that is f of x is equals to in root of x square plus 3x. Therefore the f dash of x is equals to 1 upon 2 times in root of x square plus 3x. This is the composite function and hence into ddx of x square plus 3x, which is the 2x plus 3. Therefore the f dash of 1, that is x is replaced by 1. Therefore it is a 1 upon 2 times in root of 1 square plus 3 into 1 into 2 into 1 plus 3, and overall you will get 5. That is 1 upon 2 into root of 4, which is 2. 2 into 2 is 4. Therefore f dash of 1 is equals to 5 by 4. Now what is the formula for the approximation? This is very important. That is f of a plus h is equals to f of a plus h into f dash of a. Therefore f of 1.02 is approximately equal to 2 plus 0.02 into 5 by 4, and that's calculation is 2 plus 0.10 upon 4, and that's nothing but 0.025. That is a 2 plus 0.025 is equals to 2.025, and hence the value of this function, that is f of x at x is equals to 1.02 is, that is a 2.025. This is the value. Now see this again. Now see this here. Find the approximate value of the function f of x is equals to x square plus 3x at x is equals to 1.02. X is equals to 1.02. Here a is equals to 1 and h is equals to 0.02. And this is the formula, that is f of a plus h is approximately equal to f of a plus h into f dash of a. And that's why we'll calculate the value of f of a. That is f of a means f of 1 in root of 1 square plus 3 into 1. That is 1 plus 3 root of 4, which is equals to 2. F dash of x is equals to, that is the derivative of root of x square plus 3x, that is 1 upon 2 times in root of x square plus 3x into derivative of x square plus 3x, that is a 2x plus 3. Therefore f dash of 1 is equals to 1 upon 2 into in root of 1 square plus 3 into 1 into 2 into 1 plus 3. That is 1 upon 2 into root of 4, which is 2 into 2, 4 into 5, that is 5 by 4. This is the f dash of 1. F dash of 1, that is equals to 5 by 4. f of a plus h is approximately equal to f of a plus h into f dash of a. Therefore, f of 1.02 is approximately equal to 2 plus 0.02 into 5 by 4. That is equals to 2 plus that is a 0.10 divided by 4, 0.025. Therefore, the value of that function, that is a 2.025 at x is equals to 1.02. Now we'll see the next problem. See this here, question number 9. Find the approximate value of cos inverse of 0.51 given that pi is equals to 3.1416 and 2 upon root 3 is equals to 1.1547. Now see this here. We want to find out the value of cos inverse of 0.51. Now we know that 0.51 is equals to, that is a 0.50 plus 0.01, and here the value of a is 0.5 and h is equal to 0.01. What's our function? Our function is f of x is equals to cos inverse of x. Therefore, f of a plus h is approximately equal to f of a plus h into f dash of a. Now these are the values of a. A is equals to 0.5 and h is equals to 0.01. F of 0.5 is equals to cos inverse of 0.5. That is nothing but 1 upon 2. But we know that the cos inverse, that is the value of cos of 1 upon 2 is pi by 3. And hence we write here that is the cos inverse of 0.5 is equals to pi by 3. And this is the f of a. Now what about the next? We want to find out the value of f dash of a. But what's our function? Our function is f of x is equals to cos inverse of x. Therefore, f dash of x is equals to, it's a derivative. The inverse of, that is the derivative of cos of inverse of x is minus 1 upon in under root of 1 minus x square. And it's a value at x is equals to 0.5. Replace here x as a 0.5. That is minus 1 upon in root of 1 minus 0.5 bracket square. That is minus 1 upon in root of 1 minus 0.25. That is minus 1 upon in root of 0.75. That is minus 1 upon in root of 75 upon 100. That is here is a 10 upon in root of 3 into 25. And hence that is, this is the 10 root of 25 is a 5 root 3. And if you calculate it, you will get the minus 2 upon root 3. This is the f dash of 0.5. That is a minus 2 upon root 3. Now we'll substitute here values. Now f of 0.5 that we have calculated here is a pi by 3 minus 0. That is here is a, we have the value of f dash of 0.5, it's a minus, and that's why here the minus sign. That is minus 0.01 into 2 upon root 3. and the value of 2 upon root 3 that we have given in the example, that is a 1.1547, and if you substitute it and perform their calculation, then you will get that is a pi by 3 minus 0.0114547. And what is the value of the pi? If we take the value of the pi is a 3.1416 upon 3, then you will get 1.0472 minus 0.011547, and their subtraction 1.03561, and hence our answer is that is a 1.03567. Now see this again here. Find the approximate value of cos inverse of 0.51 given pi is equals to 3.1416 and 2 upon root 3, the value of 2 upon root 3 is 1.1547. There is a 0.51, 0.5 plus 0.01. This is a and h. F of x is equals to cos inverse of x, and this is the formula. F of a plus h is equals to approximately f of a plus h into f dash of a, the value of a and the value of h. F of 0.5 is a cos inverse of 0.5, which is equals to pi by 3, that is f of a. F dash of x is equals to minus 1 upon in root of 1 minus x square, and its value is a minus 1, that is 1 upon in root of 1 minus 0.5 bracket square, that is a minus 1 upon in root of 1 minus 0.25, that is minus 1 upon in root of 0.25, that is 75 upon 100, that is minus 10 upon root of 5 into 25, that is minus 10 upon 5 into root 3, that is a minus 2 upon root 3. Therefore, f dash of 0.5 is equals to minus 2 upon root 3. F of 0.51 is equals to f of 0.5 plus 0.01 into f dash of 0.5, and its value is pi by 3 plus 0.01 into 2 upon root 3, that is pi by 3 minus 0.01 into the value of 2 upon root 3 is 1.1547, and its calculation is pi by 3 minus 0.011547. The value of pi is 3.1416 upon 3, and its calculation is 1.0472 minus 0.011547, and that's equals to 1.03565. This is the, if we take or not take above answer, that is our below the answer. only the difference in 0.00002. Now here we will start the question number 10. Find the interval on which the function y is equals to x raised to x is increasing and decreasing. Here x is greater than 0. Now here y is equals to x raised to x. Take log of y is equals to x into log of x. Take log. Now differentiate this with respect to x. Then 1 upon y into dy by dx is equals to. Here we will apply the product rule. That is x into derivative of log of x is 1 upon x plus 1 into log of x. Therefore, you will get 1 upon y into dy by dx is equals to 1 plus log x. Therefore, dy by dx is equals to y into in bracket 1 plus log x. For the increasing function, we write here dy by dx is a greater than or equal to 0. That is y in bracket 1 plus log of x is a greater than or equal to 0. That is x raised to x in bracket 1 plus log of x is a greater than or equal to 0. It means that 1 plus log of x is a greater than or equal to 0. That is 1 plus log of x is a greater than or equal to 0. It means that log of x is a greater than or equal to minus 1. And it's a value that I had written here. That is the log of x is equals to minus 1. Then x is equals to e raised to minus 1. Therefore, x is equals to 1 upon e. That is the x is a greater than or equal to 1 upon e. And hence, the given function is increasing. This is the closed interval and here is open. Where x is greater than or equal to, therefore it is a 1 upon e to the infinity. And the next for the decreasing, that is dy by dx, that is x raised to x in bracket 1 plus log of x, which is less than or equal to 0. And that's why 1 plus log of x is a less than or equal to 0. It means that log of x is a less than or equal to minus 1. And again here the log of x is equals to minus 1, x is equals to e raised to minus 1, that is equals to 1 upon e. And hence we write for the decreasing 0 to 1 upon e, which is the close. Therefore the given function is increasing in this interval. It is a closed interval 1 upon e to infinity open, and decreasing, that is a 0 to 1 upon e, and it is a closed interval. Now we'll see the next example. Now here is a question number 11. Find the interval on which the function f of x is equals to x upon log of x is increasing and decreasing. Now here f of x is equals to x upon log of x, differentiate with respect to x. F dash of x, here we will apply the quotient rule. Log of x into derivative of x is 1 minus 1 upon x into 1 upon x. Derivative of log of x is 1 upon x into x upon v square, that is a log of x bracket square. Therefore log of x minus 1 upon log of x bracket square. Now here the given function for increasing f dash of x is greater than or equal to 0. That is a log of x minus 1 upon log of x is greater than or equal to 0. Therefore log of x minus 1 is greater than or equal to 0. Log of x is greater than 1, and hence x is greater than or equal to e, and therefore the given function is increasing in the interval, that is e to infinity, where e is closed, that is equals to e. And now next for the decreasing, that is it's a derivative, that is a log of x minus 1 upon log of x, which is less than or equal to 0. Therefore if we simplify it again, you will have the log of x is less than or equal to 1. Therefore x is less than or equal to e, and hence the given function is decreasing in the interval 1 to e, where e is closed. and hence answer the given function is a decreases in the interval 1 to e where e is a closed and increasing in the interval increases in the interval e to infinity and decreases interval in 1 to e. Now the next example is an open box with a square base is to be made out of a given quantity of the sheet of area A square. Show that the maximum volume of the box is a raised to 3 upon 6 root 3. Now here let x be the side of the square base. Therefore the area of the base is equals to x square and h be the height of the box. Now see this here box, this is the base and this is the height. What about here open box? Its area of the base which is the x square and vertical surface area that is a x into h, but these all are 4x into h, that is equals to a square. This material we have given which is the a square area of the sheet. Therefore h is equals to a square minus x square upon 4h. The volume of the box v is equals to area of the base into height, that is x square into h. Therefore x square in bracket a square minus x square upon 4x. Therefore v is equals to 1 by 4 in bracket a square x minus x cube. Now differentiate this with respect to x. dv upon dx is equals to 1 by 4 and the derivative of x is 1. That is a square and here is a x cube. Its a derivative is a 3x square. Therefore its a second derivative, that is a d2v upon dx square is equals to 1 by 4 minus 6x and that is equals to minus 3 by 2 into x. Now to find out the values, maximum extreme values, we equate. To find out the extreme values, dv upon dx is equals to 0. Therefore 1 by 4 a square in bracket 3x square is equals to 0. And if we simplify this, then you will get 3x square is equals to a square. Therefore x square is equals to a square upon 3 and x is equals to a upon root 3. Now d2v upon dx square at x is equals to a upon root 3. Therefore it's a value. That is the second derivative was minus 3 by 2 into x. We'll substitute the value of this x which is a upon root 3 here and its simplification is minus root 3 upon 2a which is less than 0. Therefore v is a maximum at x is equals to a upon root 3 and therefore the maximum volume is 1 by 4 in bracket a square x minus x cube. Now here we will substitute the value of x is a upon root 3, that is 1 by 4 a square into a upon root 3 minus a upon root 3 bracket cube, and that's why you will get 1 by 4 a cube upon root 3 minus a cube upon 3 root 3, and after simplification you will get 1 by 4, that is here is a which is 3 a cube minus a cube upon 3 root 3, and hence you will get that is a cube, this is that is a 3 a cube minus a cube which is 2 a cube, that is a cube upon 4 here and 2 is here, that is a cube upon 4 in bracket 2 upon 3 root 3, and after simplification you will get that is a cube upon this 2 upon 4, it's makes a 2 and its a simplification is a 6 root 3. Therefore a cube upon 6 root 3, that is why we want to prove, and hence the answer. Now see this again. An open box with a square base is to be made out of a given quantity of the sheet of area A square. Show that the maximum volume of the box is A cube upon 6 root 3. Let x be the side of a square base and area of base is x square. Let h be the height of the box. Area of the base, that is the length of the base is x, h is the height. Area of the base, total surface area, x square plus 4xh is equals to a square. Therefore, h is equals to a square minus x square upon 4x. The volume of the box. V is equals to area of the base into height. That is x square into h, and the value of the h is a square minus x square upon 4x. Therefore, V is equals to 1 by 4 a square x minus x cube. This is the volume. Now differentiate this with respect to x to find out the extreme values. Therefore, dv upon dx is equals to 1 by 4. Derivative of x is 1. X cube is a 3x square. And d2v upon dx square is equals to 1 by 4. Derivative of a square is 0. And here is a minus 6x, and that is equals to minus 3 by 2x. It's negative. The value of x is not negative, and therefore this is the condition for the maximum. That is, we want to directly find out the value of extreme values. Therefore, dv by dx is equals to 0. That is 1 by 4 a cube minus 3x square. That is the first derivative. That is equals to 0, which is 3x square is equals to a square. Therefore, x square is equals to a square upon 3. Therefore, x is equals to a upon root 3. And that's why d2v upon dx square, it's clear that it is a negative, and which is the condition for the maximum. That x is equals to a upon root 3. That is a minus 3 upon 2. The value of x is a upon root 3. Minus root 3 upon 2a, which is less than 0. And that's why the volume V is a maximum at x is equals to a upon root 3. One by 4 in bracket a square x minus x cube. A square, the value of x is a upon root 3 minus a upon root 3 bracket cube. Now we'll simplify this. This is 1 by 4 a cube upon root 3 minus a cube upon 3 root 3. That is a root 3 cube means 3 root 3. Now we'll simplify this. That is a cube, we can take the common. That is a cube upon 4, and this simplification is, sorry, this will be that is a 1, or here we have performed the cross multiplication. It is not required a cube. Here is a 1 by mistake. It is, I will delete it. Here is a 1 by 4, and overall I'm taking the a cube as a common. A cube upon 4. Here is a 3a cube minus a cube, which is a 2. 3 upon root 3, and its simplification is a cube upon 6 root 3. This is we want to prove. Now the next example is question number 13. Show that all rectangles inscribed in a given circle, the square has a maximum area. That is, if we inscribe the rectangle in this circle, you will get the condition for the maximum, and you will get length is equals to the breadth. Now see this here. Now in figure, 2x and 2y are the length and the breadth of a rectangle. Now here is a 2x and here is a 2y. A is a radius of a circle. This is the radius of the circle. This is the y, x, and by Pythagoras in triangle, this is a right angle triangle, that x square plus y square is equals to a square. Therefore y square is equals to a square minus x square, and y is equals to in root of a square minus x square. Now what about the area of this rectangle? That is a 2x into 2y, that is equals to 4xy. Therefore a is equals to 4x, and the value of the y is in root of a square minus x square. Now we'll differentiate this area so that we'll get the maximum area, and we will, when we take the maximum condition, we'll get its length and breadth both are equal, that is nothing but the square. Okay, now this is the dA upon dx. Now the first is, we'll apply here the product rule. The derivative of x is 1 in 2 in root of a square minus x square plus 4x into derivative of in root of a square minus x square. That is a 1 upon 2 times in root of a square minus x square into ddx of a square minus x square. The derivative of a square is a 0 and x square is a, that is a minus 2 here. And again, if you simplify it, then you will get 4 in root of a square minus x square minus 4x upon in root of a square minus x square. If you simplify this again, then you will get 4 in bracket a square minus x square minus 4x square upon in root of a square minus x square. Therefore dA upon dx is equals to 4x square minus 8x square upon in root of a square minus x square. Now for the extreme condition or the maximum minimum condition, we always equate the first derivative equals to 0. And that's why 4a square minus 8x square upon in root of a square minus x square equals to 0. And therefore 4a square minus 8x square equals to 0. Therefore x square is equals to a square upon 2. And that's why x is equals to a upon root 2. Taking the square root on both sides. And here, this is the value of x. Now dA upon dx, that's we have calculated first derivative, which is a 4a square minus 8x square upon in root of a square minus x square. Now here is of dA upon dx is 4a square minus 8x square into a square minus x square is to minus 1 upon 2. Now we'll differentiate this again with respect to x. Now to avoid the use of the quotient rule, we can take this denominator to the numerator and it becomes a square minus x square raised to minus 1 upon 2. Therefore d2a upon dx square, it's a second derivative, that is a derivative of 4a square is a 0 and minus 8x square is a minus 16x into this term is as it is, which is a square minus x square is 2 minus 1 upon 2 plus 4a square minus 8x square into derivative of a square minus x square bracket is 2 minus 1 upon 2. It is a minus 1 upon 2 a square minus x square raised to minus 1 upon 2 minus 1. Its max, which is there, is a 3 by 2 into derivative of a square minus x square. The derivative of a square is a 0 and x square is a minus 2x, which is here. Now again here is a simplification, that is a minus 16x, and here is the power is minus 1. We can take here to the denominator, it becomes positive. And it is written as in root of, that is a minus 16x upon in root of a square minus x square plus 4a square minus 8x square into x upon a square minus x square raised to 3 by 2. This index will become here the positive. And now we will simplify here. We will take the LCM. Then what is the LCM? That is a square minus x square raised to 3 by 2. This is LCM. Therefore, one power will multiply here. That is a minus 16x into in bracket a square minus x square plus 4x square minus 8x square into x upon a square minus x square raised to 3 by 2. Now here we will simplify here and substitute the value of x that we have calculated here, which is x is equals to a upon root 2. Here is a upon root 2, a square, a upon root 2 bracket square, it's a square upon 2 plus 4x square minus 8 a square upon 2 into a upon root 2. And if we simplify here, that is a minus 16a upon root 2 into a square minus a square upon 2, which is a square upon 2 plus, if we simplify again, you will get the 0 into a upon root 2 and whole will become 0. And that's why you will get minus 16a, here is a cube upon 2 root 2 and whole divided by this quantity, which is a cube upon 2 root 2. That is a 2 raised to 3 by 2 means what? 2 root 2. And if we simplify this, you will get minus 16, which is the less than 0. And this is the condition for the maximum. Therefore, the area is a maximum when x is equals to a upon root 2. Now, what is the value of the y? Now, y is equals to in root of a square minus x square. That is in root of a square minus x square, a square minus a square upon 2. And if we simplify, you will get the value of y is a upon root 2. Now, it's very interesting here, that is both the values of length and breadth both are equal here. That is x is equals to y, which is a upon root 2, is that is the square has the maximum area, and hence it is a proved. Now see this here, problem number 30. Show that all rectangle inscribed in a given circle the square has the maximum area. Now see this here. In figure, 2x and the 2y are length and breadth of length and breadth of a rectangle. Let A be, that is the radius of circle, Here is x square plus y square is equals to a square. Y square is equals to a square minus x square. Y is equals to in root of a square minus x square. Now here we are finding the condition for the area, and that's why we are taking the area of the rectangle, which is equals to a is equals to 2x into 2y. That is equals to 4xy. Therefore, a is equals to 4x, and this value of the a is in root of a square minus x square. A is equals to 4x in root of a square minus x square. dA upon dx, that is equals to, here we will apply the product rule. The derivative of x is 1 into in root of a square minus x square plus 4x into derivative of in root of a square minus x square. That is 1 upon 2 times in root of a square minus x square into derivative of a square minus x square. That is equals to minus 2x. Therefore, 4 in root of a square minus x square minus 4x upon in root of a square minus x square. And if you simplify this, then you will get 4 in bracket a square minus x square minus 4x square upon in root of a square minus x square. That is, you will get 4a square minus 8x square if you simplify it upon in root of a square minus x square. This is the dA upon dx. dA upon dx is equals to 0. That is 4a square minus 8x square upon in root of a square minus x square is equals to 0. And that's why 4a square minus 8x square is equals to 0. That is a x square is equals to a square upon 2. Therefore, x is equals to a upon root 2. X is equals to a upon root 2. Now dA upon dx, that is equals to 4a square minus 8x square into, instead of applying the quotient rule, here we are applying the product rule. That is a square minus x square is to minus 1 upon 2. Therefore, d2a upon dx square is equals to minus 16x, derivative of this first term. Second term is as it is, and next is a 4x square minus 8x square into derivative of a square minus x square is to minus 1 upon 2, which is minus 1 upon 2 into a square minus x square is to minus 3 by 2 into ddx of a square minus x square. That is a minus 2x, and hence this is the minus 16x in bracket a square minus x square raised to 1 upon 2, or it is in root of. Next is, here is a minus and minus will become plus. That is a 4a square minus 8x square into x upon a square minus x square raised to 3 by 2. That is a minus 16x in bracket a square minus x square plus 4x square minus 8x square into x upon x square minus x square raised to 3 by 2. If we substitute x is equals to a upon root 2, a square upon x square. The value of x square is a square upon 2 plus 4x square minus 8 a square upon 2 into a upon root 2. And now simplify this. That is a square minus x square. The value of x is a upon, which is a square upon 2, not a upon 2. Here is a, I will correct it. Here is a square upon 2. It's by mistake. There is minus 16a upon root 2 into, if you simplify this, then you will get a square upon 2, and here is a 0 into a upon root 2. Here is a square upon 2, and a square minus a square upon 2 is nothing but a square upon 2 raised to 3 by 2. That is a minus 16a cube upon 2 root 2 upon a cube upon 2 root 2, and if we simplify it, you will get minus 16, which is less than 0. Therefore, the area is a maximum. When x is equals to a upon root 2. Now the value of the y is equals to in root of a square minus x square. That is a square minus a square upon 2 in root of a square upon 2, that is a upon root 2. That x is equals to y is equals to a upon root 2, which is the condition for the square. That is nothing but the square. When the area is a maximum, when the rectangle is inscribed in a circle, and we require the area maximum, it is nothing but that it is a square. Hence proved. Now the next is now the question number 14. Show that a closed right circular cylinder of a given surface area has a maximum volume if its height equals the diameter of the base. That is, show that, again I am repeating the question, show that a closed right circular cylinder of a given surface area has a maximum volume if its height is equals to its diameter of the base. Very interesting problem. Let r be the radius of the base and h is the height of the cylinder. The total surface area of the cylinder, that is equals to 2 pi r in bracket r plus h. This is the total surface area of the cylinder. Now here is a 2 pi r, that is, we'll calculate, that is r plus h is equals to c upon 2 pi r. Therefore, h is equals to c upon 2 pi r minus r. Now the volume of the cylinder, that is a v is equals to, which is the pi r square into h. Now here we'll substitute the value of the h, that is a c upon 2 pi r minus r. And it's a calculation, that is a v is equals to, if we multiply here, that is a r square in bracket, that is a c upon, that is a c r square upon 2 pi r get cancelled, that is a cr upon 2 pi minus r cube, that is v is equals to pi in bracket cr upon 2 pi minus r cube. Therefore differentiate this with respect to r. Therefore dv upon dr is equals to pi in bracket, the derivative of r is 1, c upon 2 pi minus 3r square. Now differentiate this with respect to, again, r, second derivative. That is, derivative of c upon 2 pi is 0. 3r square minus 6r. That is a d2v upon dr square is equals to minus 6 pi r, which is the negative. Now next, this is the condition for the maximum. It's clear that for the extreme values, we equate the first derivative equals to 0 to find the extreme values. That is a pi in bracket c upon 2 pi minus 3r square is equals to 0. Therefore, c upon 2 pi is equals to 3r square. Therefore, r square is equals to c upon 6 pi. And the value of this r is in root of c upon 6 pi. Now next is d2v upon dr square. If we substitute the value of the r, it gets a negative, and v is a maximum when r is equals to in root of c upon 6 pi. Now here, what is the h? H is equals to c upon 2 pi r minus r. And hence, that is a c upon, the value of the r is c upon 2 pi in root of c upon 6 pi minus in root of c upon 6 pi. Now simplify this again, c upon 2 pi in root of 6 pi upon c minus in root of c upon 6 pi. And again we will simplify here, that is a root of c. Here is a c in root c and here is a c. It becomes root c. Okay, here is a root of 6 pi upon 2 pi minus root of c upon 6 pi. Now we'll simplify here, that is a here this is the root 6 root of c root of 5 separated upon 2 pi minus root of c upon 6 pi. And again here we will simplify, that is what's here, root of pi upon pi. It becomes root of 5. That is a root 6 into root c upon 2 root of pi minus root of c upon, this is the 6 root pi. And here we again will simplify here, that is we are multiplying to this first term by root 6 upon root 6 upon root 6, and it becomes 6 root of c upon, this is the root 6 and root of pi. We can write here, that is the root of 6 pi into 2 root of 6 pi minus root of c upon 6 pi. And this is nothing but the height. That is, and again if we simplify this, then you will get what the simplification. This is nothing but the value of the r. That's r is equals to, and this r, this is 3r minus r, that is nothing but the 2r, and hence height is equals to the diameter, and hence it is a proof. And see this again here. Show that a closed right circular cylinder of a given surface area has a maximum volume if its height equals the diameter of base. Now here given thing is that we have given the surface area, and using that surface area we want to prove that its a max volume is the maximum when height is equals to the diameter of the base. Now here r be the radius of the base, h is be the height of cylinder. The total surface area of total surface area of cylinder is equals to 2 pi r in bracket r plus h. Therefore h is equals to that is r plus h is equals to c upon 2 pi r. Therefore h is equals to c upon 2 pi r minus r. And that's why we'll find out the volume. This is what we require, the volume of the cylinder. And we'll find the condition when its volume is a maximum. At that time, the height is equals to the diameter of the base. Now here V is equals to pi r square into h. This is the volume of the cylinder. That is the pi r square. H is c upon 2 pi r minus r. Therefore V is equals to pi in bracket cr upon 2 pi minus r cube. Now differentiate this with respect to r. Then you will get dv upon dr is equals to pi in bracket c upon 2 pi. Derivative of r is 1 and r cube is a 3r square. Now differentiate this with respect to r. dv upon dr, that is equals to pi in bracket derivative of c upon 2 pi is 0. 3r square is a minus 6r. And that is equals to minus 6 pi r. Second derivative, that is a d2v upon dr square, that comes minus, and this is the condition for the maximum. That is a minus 6 pi r. Now we'll find out the extreme values. For that, we equate the first derivative equals to 0. Therefore, dv upon dr is equals to 0. Its first derivative was pi in bracket c upon 2 pi minus 2r square. And it is a c upon 2 pi, that is equals to 2r square. Therefore, r square is equals to c upon 6 pi. Therefore, r is equals to in root of c upon 6 pi. Now the second derivative, that is a minus 6 pi r, and the value of the r is minus 6 pi into in root of c upon 6 pi. And if we calculate it, you will get minus in root of 6 pi c, which is negative, and this is the condition for the maximum. Now our next job is the relation between the height and the diameter, or height and the radius. Now here h is equals to c upon 2 pi r minus r. What is the value of r? R is a c upon 6 pi. When v is a maximum. Substitute here. Now this is the calculation. That is a c upon 2 pi in root of 6 pi upon c minus root of c upon 6 pi, that is equals to Here is a c upon root of c, that is a root of c upon 2 pi into root of 6 pi minus root of c upon 6 pi. Here is a root 6, root of c, root of 5 upon 2 pi minus root of c upon 6 pi. See this calculation, that is a root 6 root c. Here is a root of pi upon pi. It's nothing but 1 upon root of pi minus root c upon 6 pi. Again, what will happen again next? Root 6 root c upon 2 root of pi. Now simplify again. Multiply and d by root of 6. Root 6 upon root 6. Therefore, you will get this is a 6 root c upon 2 root of 6 pi minus root of c upon 6 pi. And again the simplification. This is a 3 root of c upon 6 pi minus root of c upon 6 pi. That is a 3r minus r, that is equals to 2r. Therefore, h is equals to 2r, and that is equals to the diameter. And hence, it is a proof. And in this way, we have completed the question number from 8 to 14. I hope that you would have understood the problems I had explained. Now we'll see in the next video. Till then, goodbye.